After describing the motion of an object using the average velocity formula and the acceleration formula that we used to derive Newton's equations of motion, Newton went one step further and tried to discuss why an object was moving the way it was. In order to do this, he analyzed the motion and came up with the things that relate to motion, displacement, and the change in motion and displacement or acceleration. In order to describe these, we need to start with the first and the third laws. The first law, I believe you're familiar with. An object in motion remains in motion in a straight line unless acted on by a net force. Of course, an object at rest will remain at rest unless acted on by a net force as well. Net force we'll discuss in a few minutes. The key here is that if left alone, the object will continue doing what it is doing in a straight line indefinitely forever. It's hard to get over this sometimes in physics because we will draw something like a ball or a sphere of some kind rolling on a flat horizontal table, and in the real world we would expect this to eventually roll to a stop. But if this is moving with some initial velocity and the table is horizontal, under these rules, no matter how far it goes, when it reaches over here, it will be going the same speed it was moving originally in the same direction. There is no change. However, if that object were to encounter another object and collide with it, as we saw in the momentum calculations, it's very possible that the object will experience a force. The third law describes that force acts when two objects are acting together. So the force on an object due to another object is equal and opposite to the force on the other object when they interact. This is written mathematically as the force on A due to B as a vector is equal and opposite to the force on B due to A as a vector. Often called action-reaction, it's important to note that the only way this is possible is if there are two objects acting in the system. Newton's second law really was the focus of his laws as a whole and was the investigative study that he was spending most of his time on, which was the application of net force to a particular object and how it would change the motion of that object. And what he found is that the acceleration of the object is directly proportional to the net force and inversely proportional to its mass. Written mathematically, he started with proportionality just being a general characteristic. So using the alpha as a proportion function, he described the net force as being directly proportional to A and the acceleration as being inversely proportional to the mass. Through investigation, he was able to discover that there was no proportionality constant. And so these two factors, the net force and the mass, are the sole characteristics that affect acceleration. And so this can be rewritten with an equal sign now as being the net force divided by the mass. And then in terms of clarity and organization, this equation is often rewritten to be solved for the net force equal to m times a, keeping in mind that the forces are vectors and the acceleration is vectors. So in mathematical format, this is Newton's second law. Now it's important to note that mass and acceleration are terms we've qualified already. Net force is something that is somewhat new, although not really when you think about what we're talking about. The net force, written as sigma f as a vector, is going to be the sum total of all forces acting on an object. Some forces, of course, would mean that you need to include every possible force, but it's also important that it's just on that particular object in question. And so what you're going to do to be most effective for identifying the net force is use a free body diagram. The free body diagram will isolate one particular object in question, then you will label all the forces acting on that, and then using your frame of reference and your dimensions, positive and negative, you'll determine the net force. Once you have the net force, then sigma f can be written here into the second law and solved. So another way of thinking about this is that the summation of the total forces is the total forces added together, F1 plus F2 plus F3, etc., for however many forces there are. In AP, we will address how this evolves if F1 and F2 and F3 are in multiple directions. But for now, linear directions, we'll just expect these to be either positive or negative values, all in the same dimension. Once you have the summation of the forces, we can analyze based on the relationship of the third law to determine the forces on the other objects in the system. And then using the second law, we'll use that to determine how things accelerate and change. Once we have the acceleration, then you'll know one characteristic of the motion. You'll be able to go and use your equations of motion to predict things like final velocity, time frame, and displacement.